Hello. In this episode, we will discuss creating and managing maintenance schedules in the MoldMaker system, which are one of the system's key functionalities. We log into the system. As we know, to increase the lifespan and reliability of production tools, such as injection molds or stamping dies, regular inspections are essential, for example, based on the number of completed cycles. In MoldMaker, we therefore have maintenance schedules available, which remind us about upcoming inspections. Schedules are defined individually for each tool, and you can create up to 4 independent schedules for every tool. Now we go to the settings of one of the tools, to the Maintenance Schedules section. We distinguish between 2 types of schedules, a schedule based on the cycle counter and a schedule based on date. We will discuss them one by one. In this example, we can see that one schedule has already been created, which is represented by a dedicated tile with descriptions. We will now create another schedule by clicking the Add New Schedule button. Next, we enter the name, description, select the category Preventive Maintenance, and choose one of the available options. First, we select the Buy Cycles option. This type of schedule is triggered when the wireless counter reaches the specified number of cycles. Next, we set Cycles until next reminder, which is the number at which the schedule will report that the required number of cycles has been reached. We enter 4,100,000. Optionally, you can also enter a value in the Pre-Reminder field, which represents an early warning notification. This parameter defines how many cycles before the main scheduled threshold the preliminary reminder should be triggered. An early reminder like this can be especially useful for production planners, as it gives them time to adjust the production schedule in advance before the tool is taken out of operation for inspection or maintenance. We enter 2,000. This means that 2,000 cycles before the main reminder appears, a pre-reminder will be triggered. In this case, it will occur at 4,098,000 cycles. Optionally, we can also enter an interval, for example 30,000 cycles, which determines how often the schedule repeats. Next, we either define a specific scheduling rule or leave the default setting. After saving, we can see that a second schedule tile appears. We open it again using the pencil icon. On the right-hand side, we can additionally configure the visual effect and color. For now, we will not go into the other advanced options. We will return to them later. The last parameter worth configuring is Notifications, where we select the people who should be informed and choose the notification method. It is also worth noting that next to the pre-reminder checkbox, there is a Generate Work Order option. When this checkbox is selected, the system will automatically create a work order as soon as the pre-reminder is triggered. This allows technicians to see the work order in advance and prepare for the upcoming inspection. We save and exit. Now, let's add one more schedule, this time based on a date. We click the Add New Schedule button. We enter the name and description. Select the category Regeneration and choose the By Date option. This type of schedule is triggered when the specified date is reached. Next, we set the date and define the pre-reminder, which in this case represents the number of days before the main date. Preliminary reminders will then be sent accordingly. We also define the interval and recurrence method in the Scheduling Rule field. Finally, we save. We can now see 3 schedules, 2 cycle-based schedules marked with a bell icon, and 1 date-based schedule marked with an alarm clock icon. On each tile, we can see the name, a progress bar, the next cycle value or scheduled date, the interval, the pre-reminder value in cycles or days, and the number of people who will be notified. At the top, A schedule can be deactivated if needed. For now, all our schedules are active and waiting, either for the counter to reach the required value or for the scheduled date to arrive. So, what happens when a schedule reaches its defined date or number of cycles? Let's look at an example. In the main tool register, under the Schedules column, a red bell or alarm clock icon indicates that a schedule has reached its threshold. We open the tool and see that one of the schedules is now highlighted in red. By clicking the notification icon, we can check when notifications were sent to users. The next important step in this situation is to confirm the schedule. To do this, we click the green Confirm button. A selection window appears showing the proposed date or cycle value for the next reminder, along with the rule used to calculate it. The system also suggests creating a maintenance card and a work order. You can choose yes or no for each option. In this case, we leave the default settings. We agree to create a maintenance card and choose not to create a work order. Now we press Confirm. At this point, the schedule is moved to the next value according to the selected rule, and, based on our earlier choice, the system redirects us to create a maintenance card. We fill in the details, select the category, decide whether notifications should be sent, upload photos if needed, and save. A note-based type of maintenance card has now been created. We could just as easily have chosen the checklist option and created a checklist-type maintenance card instead. It is also possible to cancel during the maintenance card creation process and exit. In that case, the card will not be created, even if we previously selected the option to create one during schedule confirmation. This gives the user flexibility and allows deviations from the standard workflow when necessary. The different types of maintenance cards and how to manage them are explained in detail in the training video titled Maintenance Cards. For now, we remain focused on maintenance schedules. We open the schedules for a specific tool. It is also worth configuring notifications using the notifications icon. For one of the schedules, we assign, for example, 2 people. This is how we create both a cycle-based schedule and a date-based schedule. These 2 schedule types are practical and easy to use in daily operations. Their setup process is quick and intuitive. Now, let's move on to the advanced scheduling features. Earlier, we skipped the advanced options, so let's come back to Previous Tool and create a new cycle-based schedule now. On the right-hand side, there is a progress bar that shows the percentage completion of the schedule. It can appear in 3 different colors, depending on the current progress and the pre-reminder settings. The Help button provides additional explanations about how the progress bar works. We also see the Start Value field. This value is managed automatically by the system, but it can be edited by experienced users if necessary. Below that is the Related Schedule option. Here we can link another schedule that will be confirmed at the same time as this one. This allows 2 different schedules to be aligned. An example of this feature is described under the Help button. Next, we see the Default Checklist option. This is used to assign a checklist that will later be suggested to the user. In practice, the selected default checklist will be shown to the technician when creating a maintenance card during an inspection. The last option is Planned Duration, where we define the expected time required to perform the inspection. This value is then transferred to the work order that is automatically generated when the Generate Work Order option is selected. Now we set the default checklist. From the drop-down list, we select Periodic Inspection for medium tools. Finally, we save. To demonstrate how the default checklist works, we will simulate the process using the Confirm Ahead of Schedule button. This option allows a schedule to be confirmed before it is actually due. In this example, we are doing it quite early. In real situations, early confirmation usually happens close to the end of the interval rather than at the beginning. The selection window appears again. The system suggests creating a maintenance card and a work order. We leave the default settings. We agree to create a maintenance card and choose not to create a work order. We confirm. The maintenance card creation window opens, and the checklist is automatically selected because a default checklist was assigned to the schedule. We choose the category, answer the questions, add photos, and save. We can now see how the default checklist speeds up the creation of a maintenance card and helps standardize inspection procedures for production tools. Finally, in this presentation on schedules, we will demonstrate the Planned Duration option. We add a new schedule, select the category, Preventive Maintenance. We set it by cycles, enter the number of cycles. We may also select a pre-reminder or interval. Additionally, we enter 8 hours in the Planned Duration field. We save. Next, we simulate a schedule that has reached the required number of cycles using an early confirmation. The selection window appears. This time, we choose No for the maintenance card and Yes for the work order. Then we confirm. The system now redirects us to create a work order because we selected the Add New Work Order option. As we can see, the number of hours defined in planned duration has been transferred automatically to the work order. After the work order is completed, the system records the actual working time and later compares it with the planned duration. We can also observe that the work order has been assigned the same category, Preventive Maintenance, ensuring proper continuity of the process. From here, you can continue working in the Work Orders module, which is explained in detail in the training video titled Work Orders. We wish you a productive and enjoyable experience using the MoldMaker system.